So how do we learn? And why does some of us learn things more easily than others? So I just mentioned I'm Dr. Lara Boyle. I'm a brain researcher here in Athens University of British Columbia. These are the questions that fascinate me. So brain research is one of the great frontiers, the understanding of human physiology, and also in the consideration of what makes us who we are. It's an amazing time to be a brain researcher, and I would argue to you that I have the most interesting job in the world. What we know about the brain is changing and the breathtaking pace. And much of what we thought we know understood about the brain turns out to be untrue or incomplete. Some of these misconceptions are more obvious than others. For example, we used to think that after childhood the brain did not really could not change. And it turns out that nothing could be further from the truth. Another misconception about the brain that is you use part of it at any given time and it's silent when you do nothing. Well, this is also untrue. It turns out when even you are at rest and thinking of nothing, your brain is highly active. So it's been advances to technology such as MRI. It's allowed to make this and many others important discoveries. And perhaps the most exciting, the most recent, the transformative of these discoveries that every time you learn a new fact or skill, you will change your brain. Something we'll call neuroplasticity. So as little as 25 years ago, we thought that after about puberty, the only changes that took place in the brain were negative, the loss of brain of cells with aging, the result damage like stroke, and then studies began to show remarkable amounts, a reorganization of the adult brain. And the ensuing research have shown us all of our behavior change our brain. These changes are not limited by age, it's a good news, right? And in fact, they are taking place all the time. And very importantly, the organization helps us to support recovery after your damaged brain. The key to each of these changes is neuroplasticity. So what does it look like? Your brain can change in very basic ways to support learning. And the first is chemical. Your brain actually functions to transform chemical signals between brain cells, what we call neurons, and this triggers a series of action and reactions. So to support learning, your brain can increase the amount of concentration of this chemical signaling that circulate between neurons. Now, because the changes happen rapidly, they support short-term memory, or the short-term memory improvement in the performance of a motor skill. The second way to the brain can change to support learning is by altering its structure. During learning, the brain can change to connection between neurons. Now here is a physical structure of the brain is actually changing. This takes but time. This such long long-term improvement on the motorcycle. Now this process is interact. And let me give an example of how. So we all have tried to learn a new motor skill. Maybe playing the piano. Maybe learning to juggle. We have had the experience of getting better and better in single session of practice. I'm thinking I have got it. And then maybe be the return the next day with those improvements from the day before that were lost. What happened? In the short term, your brain was able to increase the chemical signaling between your neurons. For some forums, those changes don't induce in the structural changes that are necessary to support your long-term memory. Remember that long-term memories take time. What you see in short term does not reflect learning. Support long-term memories, chemical changes, but that support short-term memories.